All right, let's look at a problem where we're finding the diameter of a pipe in inches. So here I've got a pipe that they're asking for the pipe in the diameter in inches. The pipe has a flow of 220 gallons per minute and needed velocity of 2.5. Right, so we're designing the inches so that we can have this velocity at this flow. And so the first thing that we're going to have to do is this is a you've got a velocity here, right? This is a QVA problem, a variant on a QVA problem, and so I can't really do gallons per minute with QVA problems. So we're going to have to get that to cubic feet per second. If by chance I had given you the flow in cubic feet per second, you wouldn't need to do step one. All right. So once we get over the flow into cubic feet per second, we can take the cubic feet per second divided by the velocity, and this will tell us the cross-sectional area in feet squared of the pipe. And so the next step is to take that area in feet squared and set it equal to the formula 0.785 d squared. Work it mathematically, and we're going to get some number equals d squared. And so what we want to do is we want to take the square root of both sides, and so that will give us, d equals the square root of whatever this number is. I think on a TI-30 they call this like the square root x key. And then realize that the area is coming out in feet, and so we will convert it to inches. So let's go ahead and get our 220 gallons over to cubic feet. Let's take care of the time base first. I need to cancel the minutes. So 1 minute is 60 seconds. Let's take care of the gallons and add the cubic foot. A cubic foot on top is 7.48 gallons. And so now I should be at the point where I can convert this to a flow. So 220 divided by 60 divided by 7.48 gallons in a cubic foot says that I have a flow of 0.49 02 cubic feet per second. Okay, let's go ahead and take this guy and divide it by my velocity. 4902 feet cubed per second divided by a velocity of 2.5 feet squared. I'm sorry, feet per second. And so what's going to happen is one of the seconds are going to cancel, and one of these is going to take out one of those. And so the answer will come out in the cross-sectional area feet squared. My number here divided by 2.5 feet per second says that I've got an area of 0.19 square feet. Okay, let's drop that one down here. And set this equal to the formula for area, right? So we're doing here step 3, the formula for area. And so this is feet squared equals this formula. Whatever I do to one side, I can do to the other. Divide this feet squared by 0.785. And so this yields, d squared is going to equal, let's round this off, 0.25. Okay, so d squared, 5. Let's take the square root of both sides. And so this says d is equal to 0.5 feet. And then the last step, 0.5 feet converted to inches, 6-inch pipe. And that is how you do this. This one's a little bit more challenging of a problem, and so you're probably looking certainly a T4, a D4, maybe even a D5 problem.